So as we're continuing with the first part of this lab here, we are going to manipulate some of the metrics in our network to see how it affects routing throughout the inner network. Now right now you notice that Dave has redundant links. It has a link to Jade and it has a link to Beck, as well as Jade having a link between Jade and Beck. Now, what were to happen if we were to tell the routers this link here between Jade and Dave is a 10 meg link, or a 1.5 meg link, or something less than the 100 meg fast Ethernet link that it currently is set up as? Now, EIGRP, as you'll recall, uses bandwidth and delay as its default metric calculations. And EIGRP doesn't actually read what's on the interface, it uses what's configured as the bandwidth for the interface. Now, by default, the bandwidth speed matches the physical interface speed. So, for example, if we were to go on here on Jade and do show interface fast Ethernet 0/1, you see that the interface is set up as a full duplex 100 meg, 100 base T. And as a result, the bandwidth is set to 100,000 kilobit, the delay of 100 microseconds. Now again, most of the time this works perfectly. If you have a fast Ethernet link, obviously you want to use a fast Ethernet connection. However, there may be cases where the physical link speed does not match the logical link speed. For example, for MPLS links may be delivered as a gigabit Ethernet interface to you, but you may only have 30 megabit of MPLS traffic across that link. In this case, you would want your routing protocol to make its decision based upon that 30 meg subscribed circuit bandwidth rather than the full 100 megabit or full gigabit. So in this case, we're going to find the link between Jade and Dave and go on both ends of this link and tell it that it is a 1.5 meg T1. But first, we're going to take a sample of the EIGRP topology table from Rose and John just to see if the topology table out here is affected by this link over here that's actually behind Beck's router. So let's go to Rose and do show IP EIGRP topology. Obviously, everything has one successor, which is its next upstream router. Same thing for John. We'll do show IP EIGRP topology. So let's go on to Jade and let's do show CDP neighbor to see what interface we know Dave on. Dave is known on fast Ethernet 0/1. Do show IP interface brief fast Ethernet 0/1, and that is 192.168.1.22. So if we look over here on John, that particular network, the 192.168.1.20 network, is right down here and right now has a feasible distance of 33,280 with a reported distance from the neighbor of 3720. So let's go over here to Jade. We'll go into config T, interface fast Ethernet 0/1. We'll issue the bandwidth 1544 command, which is a full T1, and we'll close that out there. We'll do the same thing over here on Dave. We'll do show IP interface brief, and it's fast Ethernet 00 on Dave, so config T, interface fast Ethernet 0/0. Do bandwidth 1544. Let's go ahead and write the config on both Dave and Jade. And now let's look at the route table on Jade. So we do show IP route. We now see that .16 network, everything goes through 192.168.1.13. It doesn't send any traffic to Dave, and we no longer have two routes to that network because only one route was installed in the routing table. So if we do show IP EIGRP topology, and let's look at that 10.10.2 network now, you'll notice that the metric for this link between Jade and Dave has just gotten huge. It's now 1.7 million as opposed to 158,000 like most of these other routes. And you'll notice that we no longer have a route with more than one successors. Even that .16, where it had two successors before, now only has the one successor because the reported distance is much higher than the feasible distance now. So did that change make it all the way over to Rose and John? So let's go over here and we'll do show IP EIGRP topology. If we go down to the bottom down here, look at that network for 192.168.1.20. Look at the metric for that. It is much larger than it was before. If we scroll up here a little bit, 192.168.1.20 used to have a metric of 33,280. But because we have so lowered the bandwidth between Dave and Jade, now this metric is just incredibly high. So now you can get a very good idea of exactly how the bandwidth can affect the metric calculation all across the network. So that's why it's important to have the bandwidth statement set correctly on all of your interfaces. Again, if you've got a T1 or a fast Ethernet interface and it's actually running at that speed, no need to go modify the bandwidth. But in this case, we only have 1.5 megabit across that fast Ethernet connection, so we had to specify that in the configuration so that the metrics would be set properly. And that pretty much concludes the initial lab for EIGRP configuration. Stay tuned, we're going to cover EIGRP authentication in the next video.